Hi guys, in previous videos we had talked about vertical and horizontal shifts. We had talked about vertical and horizontal stretching and shrinking, and the final type of transformation that we're going to talk about is reflection. To be more specific, we're going to talk about reflection about the x-axis and reflection about the y-axis. So it says consider the graph of f of x. Then what is so special about the graph of negative f of x? So the special thing about the graph of negative f of x is that it is a reflection across the x-axis. So you can either remember that or you can just try to build it. So let me go ahead and illustrate it. So let's just say I have some point, something that fits in here. Say 2, 3. Okay. And then we were asked to graph f of negative x. So the question is, I said it wrong, and we're asked to graph negative f of x. Sorry about that. So in this case, what is changing? Are we changing the x value or are we changing the function value? So as you can see, we're changing the function value. So we're going from, say, positive f to negative f. Okay, so if the function value is 3 and we want negative f of x, then we want to switch it up to negative 3. So let's go ahead and locate to negative 3, and let me go ahead and label it for dramatic effect. So we went from 2, 3 to 2, negative 3. So we notice that this point is 3 units away from the axis. This point is also 3 units away from the axis, the x-axis to be more exact. So to go from 2, 3 to 2, negative 3, we had to reflect about the x-axis. And this is what this is saying. Consider the graph of f of x. What's so special about the graph of negative f of x? The special thing is that it's the reflection of f about the x-axis. Okay, so let's go ahead look at where am I? Reflection about the y-axis. Oh, sorry, I guess that was the spoiler alert. Okay, so we are asked to consider the graph of f of x, and then the question is, what is so special about the graph of f of negative x? So the special thing is that the graph of f of negative x is a reflection of f about the y-axis. I'm supposed to say across the y-axis, but that's how I was taught. Okay, so let me go ahead try to illustrate it. I'm going to graph the same point, which I believe was 2, 3. And then I want to ask myself, what is changing? Are we changing the x value or are we changing the function value? We're changing the x value. So we want to go like per se from positive x to negative x. So we're changing the function value. So if I'm at 2, 3, we're changing the x value. We're going to be at negative 2, 3. So negative 2, 3. I think I wrote it right. So we notice that this point is 2 units away from the axis, the y-axis, and this other point that we bounced off is also 2 units away. So what's so special about negative 2, 3? Well, it's a reflection of this point 2, 3 about the y-axis. And this is what this is saying here. If we have some function and we're asked to graph f of negative x, what's so special about the graph of f of negative x? Well, that's just a reflection of the graph of f about the y-axis. Cool. All right, so let's go ahead and do our first and only fun problem. I lied, it should have been 2. Give me a sec. Okay, sorry about that, guys. I thought I had lost my my notes. Okay, so it says the graph of f of x is given. Graph the following transformation, and then write the equations of the parent graphs and the equations of the new graphs. So this is the graph of the square function, so you can write y equals x squared, or we're gonna go ahead stress function notation just for fake extra credit. Okay, and then we are asked to graph negative f of x. So then I'm like, okay, where is the change being applied to? Is it being applied to the function value or to the x value? And as you can see, that negative sign is being applied to the a function value. So I'm like, okay, so it's gonna be, we have a negative, so it's gonna be a reflection. We can either remember like if it's gonna be about the x or y axis, but I rather built it, so I'm just gonna just write not 2 3 but just x y, and then I'm gonna see if I'm gonna change it to, if I'm gonna change the y, if I'm gonna change the x. In this case we are changing the function value, so we're gonna change the y. So we want to go from positive y to negative y, so it's gonna be a reflection about the x-axis. So let me just put a reflection about the x-axis. Okay, so in this case we are at 0 0, and if we're already on the x-axis, so if we reflect it, we're still on the x-axis. Then we are at 1 1, and then if we reflect it, we're 1 unit away, we should be 1 unit over. Then we are at 2 4. Here's 2 4, and if we're 4 units away, when we bounce back, we should be 4 units away. So I'm going to fill in a little bit secret. So I try to stress the word reflection, but I'm going to fill you in. So I can write this as -1 times f of x, and if I see it like this, then we have that c equals -1. So we're just going to take all the function values and multiply by -1. So if I'm at 1 1, multiplying the function value by -1, that will give me a 1 -1. Got it. This one over here is 2 4. If I multiply the function value by -1, that will give us 2 -4. Okay. All right, the next one over here, I believe is -1 1. If we multiply the function value by -1, that will give us -1 comma -1. For the grand finale, I believe this is -2 -4. Oh, sorry, I said it wrong. I believe that's -2 4. If we multiply the function value by -1, that will bring us down to -2 -4. And then we have more than enough points to do a nice smooth curve. And then just do a quick sketch right here. This one I'm not submitting for credit, that's why it's horrible. But yeah, as you can see, this is a reflection about this graph. This is a reflection of this graph about the x-axis. So what is the equation of the new graph? I know you're on it, but I'm not. So let me just write the function of the that we had before, and then the function of this one. You can just put the answer, but let me tell you, we have the function, and then we multiply by negative. So we have f of x equals the function, and then we multiply by a negative. Fantastic. All right, so let's go ahead, do another fun problem, and that'll be the end of this video. Give me a sec. Okay, that was a quick transition. Okay, so we have the graph of f of x, and then we are asked to graph f of -x. So we have a negative sign, so it's some kind of reflection. So let me just go ahead, right, reflect about the something axis. So again, you can either remember, if we have negative f of x, then we reflect about the x-axis, and if we have f of -x, then we reflect about the y-axis. But what I recommend is that you understand as much as you can, and then memorize what you absolutely have to. So let me go ahead and do the same strategy. I'm just gonna locate a random point x, y. I don't even put ordered coordinates, sorry. And then we want to go from x to -x, so that will be over here. So to go from xy to -xy, we have to reflect about the y-axis. Okay, so let's go ahead and do that. So we are at 0 0, and if we reflect about the y-axis, then we're already on the y-axis, so we will be at the same point. The next one is, I believe, 1 1. I should zoom this in. Sorry, my accent gets in the way at times. Okay, so I'm at 1 1. If we reflect about the y-axis, I'm 1 unit away, so I should be 1 unit away to the other side, so I should be at -1 1. And then the next one is 4 2. So if I'm 4 units away from the axis, I should be 4 units away on the other side, so that should bring us to -4 2. Oops, I missed the mark. It's okay. Teacher will still give me full credit. So let's go ahead, write the equation. So you can put y equals, but we're trying to stress function notation. So we have f of x equals, this is the graph of the basic function square root of x. And what is the equation of our graph? So I'm going to go ahead and put this answer. So we have that the function of the graph of the left is f of x equals square root of x. But we wanted to graph f of negative x. And I know you're on it, so you can go straight to answer, but I'm not. But this is my thought process. I'm just going to substitute a negative x for the input of x, and that will give us square root of negative x. So the equation of the graph that we just did is given by, oh, that is terrible. Sorry about that. I forgot that I already put the equal sign. The equation of the graph we just did is given by f of x equals negative x. And then if you're ever curious if you did it right, you know what, for fake extra credit, let me go ahead and zoom out. So this is what happens when you do impromptu things. The graph is a little bit dark. Okay, that's as bright as it's getting. Okay, sorry. Okay, so we have the graph of, give me a sec. We have the graph of f of x, which we said was the square root of x. Cool. All right. And then we had said that the graph of f of negative x is given by the square root of negative x. So then, moment of truth, did we really nail it? I hope so. I hope so. Okay, we'll hit graph. The first one should go to the right, just like we said. The next one should go to the left, just like we have it. So yeah, so we have a visual confirmation from our calculator that we nailed it. Yeah, this is not a square function, so I mean a square window. Let me just put zoom square, just so it looks a little bit nicer. Yeah, it looks the same probably. All right guys, that's my time. Thank you.